Welcome back to the Linux Academy Nginx Deep Dive. In this video, we're going to take a look at how to use microcaching, which is short-term caching, in order to improve the performance on applications that might have rather dynamic content, but you know is not going to be updated every millisecond. You know, it's something where you can have caching for a very short amount of time, but if you are under an extreme amount of load, you can actually get a lot more performance out of Nginx and a lot more performance out of your application server by using this trick known as microcaching. So to demonstrate this, we're actually going to utilize a load testing tool called Boom, and then we're going to be working with the uWSGI application. Once again, what we're doing right here could totally apply to using the proxy pass stat like type of proxying or the fast CGI proxying. But in this particular case, I wanted to show it with the uWSGI application. The first thing we're going to do is we're going to pip install Boom. And we're going to want to make a request to notes.example.com. And we're going to do this so that we're using 30 concurrent users and making 3,000 requests. And then we're going to do a compare contrast on what happens when we do that to the server right now versus what happens when we do this to the server with microcaching enabled. So to do this, we're going to use Boom, and then this is going to go to localhost. Then we need to pass a header, and this is going to look a little weird because we don't pass it in the normal string, so it's going to be host:/notes.example.com, and there's no space in between the colon and notes like it was when we were passing this to curl, so that's one thing to notice. And then C for concurrent, so it's going to be 30 concurrent, and then we're going to do 3,000 total requests. This is quite a few requests, and it's taking quite a while. Granted, we're working on a relatively small server, and we only have one instance of this application running. uWSGI is going to be running a couple different processes, so we have the equivalent of roughly two different Python processes that would be handling these things. But we can see that it took 15 seconds to do 3,000 requests, and it has requests per second of about 190, which is pretty good, all things considered. I mean, which is what it tells you right here. The Boom speed index it thinks that what we did there was pretty good, but I think we can do a lot better. And we're going to use microcaching to get that done. All of the directives that we're going to use inside of our notes are going to be the equivalent that we've already seen. So we're not going to see any new directives. We're just going to use them in a slightly different way. So we're going to use the uWSGI version of all these things, but it's going to be cache path. And then we're going to call this var cache nginx, and this is going to go micro. It's going to have that exact same levels, :12. And then the keys zone is going to be micro with 10 megabytes with a max size of 1 gigabyte. And we're not going to set an invalid because it would never make it that far with what we're going to actually be doing. We're going to set a uWSGI cache key. And this is once again going to be scheme, request method, host, and request URI. And then when we go down into our main location, this is where we're going to add our caching. We're going to add the add header x cache status so we can manually test this ourselves with upstream cache status. And then for the caching side of things, we're only going to set two of these. We're going to set the uWSGI cache, which is going to be micro, which is the name we set up above. And then the other one is going to be uWSGI cache valid. Whoops, need an underscore there. And then this is going to be 10 seconds. So this is the big difference. This is the difference between the caching we did previously with the static content that we knew wasn't going to be changing and the relatively dynamic content that we're going to have on this notes site. Specifically, the notes landing page pulls in the most recent note that any user in the system has created and just demonstrates its name. It'll say, oh, this person wrote this note. So that means that it could update itself pretty frequently, but we want that to be relatively up to date for the people who come to our site. But if we get a lot of requests within a short amount of time, then we only want to make one of those requests. Specifically, this is going to have us making one request to a single key, so a single page, every 10 seconds. And then after 10 seconds, we're going to be making a new request again. But every other request within that 10 seconds for the exact same page is going to be served out of the cache. And this is allowing us to essentially invalidate the cache every single 10-second interval and still serve semi-dynamic content in that case. So it'll seem like it's almost not cached. But let's save this. No more talking. We're going to make sure we didn't type anything wrong there. So we need to systemctl reload nginx. And now we're going to push up a few times till we get to that boom line again. And we're going to run this. And as you can see, it's flying through what's going on here. So that's telling us already that we're handling these requests quite a bit faster. So we did 3,000 and it took us 6 seconds. Remember that before it took us, 15 seconds? But this time around, it took us 6 seconds. So it did 190 requests per second before, which is this RPS. We just did 446. So we were only caching for a 10-second period, but even doing that minimal amount of caching, we got a huge performance gain out of this. And if we go and we actually take a look at here, we'll do it this way. Go back to our network tab. And if we do notes.example.com, we can see that it directed me right into this page. And that is going to be a cache miss. I took quite a while to get back to this. It's going to be a cache hit. But if I wait and wait and wait and wait a little bit more, and I reload this page, we're going to see that the cache had expired for this exact same thing. If I refresh again, you're going to see that it was a cache hit because when I hit it and it had expired, then that was me refilling the cache for another 10-second period. So this is a video about kind of an obscure topic, but it's just looking at what it can mean to really modify the configuration of your cache to get a little bit of extra performance out of it with something where people are, this Notes platform is essentially kind of like a Twitter in a way, right? Like you could go and you can make new posts that would show up. And so since you have dynamic content from users, then that's one of those situations where you can't really cache things all the time, but that doesn't mean that you can't cache things for a short amount of time if it's okay for you to wait a few seconds before somebody actually sees a piece of content. We more than doubled our requests per second, which means that we had we had that much more time to be able to handle normal requests that are coming through, or even a higher load than what we're actually used to before we really need to scale out our servers, because we can just rely on nginx to serve up a lot of content from the cache. And if we really wanted to test this even further, we could just change the concurrency level of what we have. So we have 30 currently. I have no idea what it's going to do if we change it to 50, but it's going to go and churn through these things. And it's still going relatively fast. So we'll see what kind of... It still only took 6 seconds. So the response per second was still, about the same here, even though the concurrent users was even higher. So we still were gaining a lot of performance there. You could handle a lot of requests for this. So that's microcaching.